So I'm here to explain problem 2.7 from the problem solving worksheet on electric fields 2. First off, the problem reads as two charged spheres, each of which is suspended from the end of a piece of very thin thread, which means that the force of the string and the mass is basically non-existent, are attached to a common point of suspension as shown to the right, or in this case on the screen. Each sphere has a mass of 40 grams and each piece of thread has a length L is equal to 18 centimeters long. Each of the two spheres is given a net charge, and as a result, the two spheres repel one another until the angle between the vertical and either of the two charged objects is 8 degrees. The charge of Q1 is negative 7 nanocoulombs, and the charge of Q2 is positive 7 nanocoulombs. Determine the magnitude of the electric field that enables the spheres to stay in equilibrium. Okay, so for this, we know that Q1 and Q2 are opposite charges, which means that they technically, without the field around them, should attract to each other. But because they don't, and they don't move farther away from each other, we know that the attraction between Q1, which is negatively charged object, its attraction to the positive end of the field is equal to the attraction it experiences to Q2. So knowing that, we can set up the equation of k q1 q2 over r squared is equal to EQ, which means that the force exerted by Q2 on Q1 is equal to the force exerted by the field on Q1. And so we just find all the values that we need. We're given Q1, Q2, and so all we need is r squared, which we can find to be 2 sine of 8 degrees times 8 centimeters, and then convert into meters for the equation, and you get 0.0501 meters. So you just plug in all the values, and for K, 9.0 times 10 to the 9th newtons times meter squared over coulomb squared times 7 times 10 to the negative 9th coulombs of Q1 divided by 0.0501 meters squared. The quantity 0.0501 squared meter squared for the radius, and then you get E is equal to 2.52 times 10 to the 4th newtons per coulomb. And I hope that helps. Thank you.